All right. The first type of question that we're going to look at today on Delta Math is the guided particle motion question. So what this is going to give us, it says change the velocity of the bunny in order to make the position function of the bunny appear like the target position graph. So what you have to do is kind of look at the target position graph and see what sort of happens after you make the correct graph. Answer the questions about the motion of the bunny. So what we have here is a little number line that represents velocity. So 0 means that the bunny is moving right, and higher values on the position graph mean right, and lower values on the position graph mean left, and 0 is sort of our initial position. So a few tips. It says your position graph must have the same concavity in intervals of increasing and decreasing. So it doesn't have to be perfect, but it just has to kind of have like the general overarching trends in the graph. So let's actually kind of do this. So the first thing that you're going to do is you're going to think about the target starting velocity. And what we notice here when we look at target velocity and starting velocity is we want to kind of look at the tangent line here. And what I notice is that it has a positive tangent line at t equals 0. And I would like you to kind of just watch this and take notes sort of what you think are the key points in this example. And it really is kind of neat. I do kind of suggest putting the general shapes of the graphs and the points, you know, like A, B, C, and D, which are kind of like our pivot points to help us answer the question. So I think it is good to kind of put your rough graphs on there. So what we can kind of see here is that we have a choice of starting velocity. Now, obviously, we have a positive sloping line, so we need to be choosing a positive starting velocity. And what's kind of going on here is that we are kind of going less in a positive slope and eventually seeing some decreasing velocity. And at about point B or so, we have an inflection point at point B. So this is where our velocity is going to kind of bottom out. So the velocity bottoms out there. And then we're going to kind of see some increasing velocity again to 0. And then we're going to be seeing a decreasing velocity. And I think we can also kind of notice here that we are concave down up until B. And then from B to C, we are concave up. And then from C to D, we are concave down as well. So I do think it's kind of good to give yourself a little bit of some observations of the graph. So I'm even going to kind of put that on the side here. Make observations about your graph. So things like instantaneous slope, concavity especially. So concavity tells us about, so instantaneous slope tells us about velocity, and concavity tells us about acceleration. All right, so let's move the bunny, shall we? So what's happening here? I'm just going to kind of narrate. So we start at a pretty substantial positive slope, and we are going to plateau when we hit a 0 velocity. And then we're going to kind of get steeper and steeper into a negative slope. And we hit an inflection point, and then we go down, and we're going to sort of plateau out at 0, and then we're going to go back down in our slope. Okay, so what happens here is that we have come up with sort of a position graph that matches our target position graph, and it also is going to provide you with the velocity graph too. And what's great is that you can kind of see that they are side by side, so to speak. So it will not let you move on until you are correct. There's actually some pretty cool things here. You can actually replay the animation. So you can kind of see how he's like moving right first, and then he's going to be moving left, and then he's going to be kind of just constantly moving left eventually. So you can kind of see that he actually is getting, much farther to the left of 0. And now we can kind of look at the position. So the first thing that we want to do is we want to kind of look at moving. So moving is either to the right or to the left. So obviously, if you are for moving up is to the right, and down is to the left. Let's actually kind of fill that in. So from 0 to A, we're going to the right. And then from A to B, we're kind of moving to the left. And then from B to C, we're moving to the left. And then from C to D, we are also moving to the left. So that gives us the moving. Now the velocity, I kind of advise looking at V of t graph for that. So we'll kind of make a note here. So V of t. And if it is greater than 0, it's positive. And if V of t is less than 0, it's negative. And what we can kind of see in our velocity graph here is that we are positive up until A. And then from A to B, we're negative. We're still below 0 from B to C. And then from C to D, we are also below 0. And then it's asking us whether velocity is increasing or decreasing. So this is actually going to help us with our acceleration. So one thing that we kind of noticed, there's really 2 ways that you could kind of look at this. One is sort of this notion of concavity. So anything that's like concave down would be decreasing, and anything that's concave up would be increasing. So we can see here that we are concave down and concave down again until B. And then from B to C, we're concave up. And then from C to D, we are concave down. So what that means is that when we're concave down, we are seeing decreasing velocity. And we are also seeing that the slope of V of t is also going down too. So another way is that you could just look at your graph of V of t, and if it has downward slope, that means that velocity is decreasing. And if it has upward slope, that means that velocity is increasing. Then we have a increasing from B to C, and then we're seeing a decreasing velocity again from C to D. So we can see that it's kind of going down. For acceleration, decreasing velocity means that your acceleration is going to be negative, and increasing velocity means that it is going to be positive. So I will say that these two rows kind of play hand in hand. Okay, so what we're going to kind of do now is we are going to then look at speed. So this is, for speed, a good question to kind of think about here is, are we moving towards zero or away from zero? And I should say, are we moving towards or away zero velocity? So obviously from 0 to A, we are moving towards 0, so our speed is decreasing, but when we kind of look between A and B, we are moving away from 0, so that speed is increasing, and then we're moving back towards 0 from B to C, so we are decreasing in speed, and then we are increasing as we are moving away from 0. And then it's asking us for at rest. So this is asking us when is the velocity equal to 0? And obviously, on this one, we are not looking at endpoints, but we are looking at 2 points where it is 0. So it's 0 at A and C on the V of t graph. And then we're just going to try the answers here. And we got them all correct. And you just submit, and then you can enjoy the work of the check mark. So this is, I think, definitely some really good practice for you just to conceptualize the different types of problems with particle motion. So sort of the, the direction that things are moving, the velocity, and the acceleration as well. The first few times that you try this, I mean, it may be, something like you've never done before, but I really encourage you on this one to experiment. And I think it would be really fun. So I think you should just capture kind of the key points that we kind of talked about here, and definitely make sure that you are including the graph of the position function and the velocity function, because that's what we are kind of using here. And it may take it a few tries for you to come up with the pattern, but feel free to kind of continue listening to the video here or the instructional video as well.